Hello, this is Tyler Beamer, Haywood Community College. It's an instructional math video for DMA 040. This is in regards to section 6, titled Further Solving Equations. So we have learned how to solve equations using addition property of equality and also multiplication property of equality. So we want to look at essentially combining those two together, solving some more complicated equations. So the book provides a step-by-step guide to doing that. We've already talked about a lot of these. Let's go through these again. Step 1, if your equation contains fractions, you can multiply both sides by the lowest common denominator to clear the fraction out of the equation. So we can look at some problems dealing with that. You can also solve the equation with the fractions in it if you so desire, either way. Number 2, distribute if there's distributive property in the equation. Step 3, simplify, combine like terms. So we've stressed the need for simplifying before you solve. Step 4, use the addition and subtraction property to isolate the variable. Step 5, use the multiplication or division inverses to get the variable completely isolated. And then step 6, check the solution. So we've actually done the majority of these steps. So this will be reinforcing what we've already learned. Alright, so let's take a look at some examples here. So if I cover up the left hand side, I've got like terms, right? 17 and 3, 20. The right side, I've got like terms, 15 minus negative 6 is going to give us 21. Okay, so that's the simplifying part. Okay, so now I want to isolate x. So I want to use my adding, subtracting inverses. So this is a positive 20, so I'm going to subtract that from both sides to cancel that out. So I get negative x, or negative 1x, equals 1. 21 minus 20 is 1. Then we want to finally use the division inverses. Divide both sides by negative 1, which just changes the sign. So we get x equals negative 1 as our solution. You have already probably solved equations similar to this in other sections. So like I said, this is really reinforcing what we've already practiced. Okay. So we've got some fractions in here, right? You've got a couple of different options here for solving this. I'll show you two different ways. What I would do first, one method, there's nothing to simplify here on either side, so we would go ahead and start using our adding, subtracting inverses to isolate a. So subtract 1. Then remember, we can multiply by the reciprocal here to get rid of that fraction. So multiply by 5/3 and we get 35 over 3. So that's one way to solve the problem, probably the easiest way. Alright, here's another way to solve the problem. Since this has a fraction with a denominator of 5, I could multiply every part of this equation by 5. That keeps the equation balanced. It also gets rid of this fraction because 3/5 times 5 is going to give me 3. Notice I multiply all parts by 5, so I essentially did this. Distributed 5 through. And so then I can continue to solve without having fractions in the equation itself. and I would still end up getting 35 over 3. For this particular problem, I think it's easier to do it the first way, the first option. Let me create a problem here in which it might be good for you to actually multiply by the LCD. So let me write a problem out here. Let me get a blank piece of paper. Okay. So let's say that we had that. So that problem has quite a few fractions in it. So instead of actually working this out with the fractions, what we could do is we could multiply by the LCD. And the LCD is the lowest common denominator, especially the smallest number that 3, 6, 4, and 2 will divide into evenly. So that, in this case, would be 12. So if I multiply all parts of this equation by 12, right? 12 over 1 times 6 over 3. So this is going to give me 24. 12 over 1 times x over 6 gives me 2x. And so what I'm doing here is I'm essentially multiplying fractions. This has a common factor of 3, this has a common factor of 3, so I'm dividing those out and then multiplying across. Same thing here. 21, 3x over 2 times 12 over 1. So this equation and this equation are equivalent. Notice this equation has no fractions in it. So that works out really nice. So now I can solve like I normally would. I can subtract 2x. Subtract 21 from both sides. Divide both sides by negative 20. So we get negative 3 over 20 is equal to x. Sorry. Which would be our solution. So I just made that problem up on the fly, so it doesn't work out perfectly. But that gives you an idea of a type of problem in which you could, multiply by the LCD to get rid of fractions. You could work it out with the fractions. A lot of calculators now will do fractions, so you can use the calculator to work with all of the fractions essentially. But that's completely up to you. Alright, let's get another example here. Okay, so we want to simplify first. So we want to distribute that 7. So 7x minus 21 equals 9x minus 7. Okay, so that's the simplifying part. So now we can start to solve. We want to use the adding, subtracting inverses. So let's get our x's together. So I'm going to minus 7x from both sides. Okay. Then the next step would be to add 7. That further isolates our variable. So that's going to give me negative 14. Then finally use my multiplying dividing inverses. Divide by 2. Divide by 2. X equals negative 7. Okay. All right. So another solving. We do have fractions here. So what I would recommend doing here is to multiply both sides by 5. And so, well, you can distribute the 3 in the numerator if you want to go ahead and take care of that. Then I would times by 5, times this side also by 5, keeping the equation balanced. So the 5s are going to cancel over here, leaving you with that numerator. And then I got to distribute the 5. I got to multiply the 5 to all parts of that expression. That keeps the equation balanced. Then I can start solving. So I would get the y's together. So do the adding, subtracting inverses here. Minus the 30. Finally, do the division. So y equals negative 3. Okay. Alright. Okay, so this is actually a new type of problem that we haven't done yet. So let's just start solving this out. The left-hand side can't be simplified. A lot to simplify on the right-hand side. So I could start by distributing the 2 through. So 2x plus 2. Then combine the like terms. And then look what happens. I'm going to try to solve for x, so I'm going to minus 5x from both sides, but the variables just completely go away on both sides, so I have no variable left. So this is a special type of equation. So if that happens, look at the statement that you have left. Right? In this case, I've got negative 5 equals negative 5. Well, that's a true statement. So what that tells you is that this specific equation has solutions of all real numbers. So essentially every number is a solution. And if you look at this part of the equation, it's kind of evident. I mean, I've got 5x minus 5 equals 5x minus 5. I have the exact same thing on the left and the right hand side of that equation. So it doesn't matter what I substitute in here for x, right? That number is going to be the same in both sides, and I'm destined to get a true statement where the number on the left and the right hand side of the equal sign are identical. So any number that I plug in there is actually a solution. So that's why we say all real numbers. Now this only happens when the variables just cancel and go away. So if you work an equation and the variables cancel, then that's obviously a hint that you're going to have all real numbers. Okay, so here's another type of equation that's also new. Okay, so we work through it like normal. Alright, so nothing to simplify on the left hand side. I can distribute on the right. Okay, Start to solve. Once again, the variables just cancel, right? 3x goes away. Look at the statement that's left. Now in this case, you get a false statement. -7 does not equal 3, right? So once the variables cancel, you get a false statement. We get no solution, right? There is no possible value for x that's going to make this a statement true. And once again, this step is evident to that. 3x minus 7, 3x plus 3. Well, when I plug in the value for x here and multiply it times 3, I'm destined to get the same number for this part and this part. So if I take the identical number and I subtract 7, and I take the exact same number and I add 3 to it, I'm never going to get the same value there. So there's no way that these results on both sides of the equal sign are going to be equal. It's always going to be something that's not equal. Therefore, there would be no solution to this equation. There's no value of x that's going to give me a true statement. Okay. So hopefully those examples will get you started here with this particular problem set. If you have any questions, as always, email me those or stop by the office. Have a great day.